So these are the three controllers that we have: vBond, vManage, and vSmart. Each one has got its own role to do. For example, as an orchestrator, vBond provides the connectivity, the bondage. That's why vBond. It helps to identify our edges and connect the edge devices to vManage and vSmart. That's the purpose of vBond. Without vBond, vEdges cannot reach, cannot know the location of vSmart and vManage. So it's only through vBond. How vBond knows the vEdges, the WAN edges? vBond knows through vManage. In vManage, we can manually provide the information about the edge device that will be connected. Can also be learned through Cisco's portal. We'll talk about those things later, but you know those things. You have already told me you heard someone speaking on that. So vBond receives all those information and wait for the edges to come and register. vBond knows earlier that there are edge devices with so and so serial number, so and so certificate is going to come to me. And vBond waits for it, and when vEdges come and register, the WAN edges receives the location of vManage and vSmart through the vBond. vManage is for the management, as we know. We configure templates, we put the features inside the template for interfaces, LAN interface, WAN interface, things like color, site ID, system ID, and many more things through vManage. So it's through vManage that we assign the policy, the routing policy, everything we do only through vManage. It's a single point of configuration. It's a single plain glass that we have to see the entire fabric. vManage. And vManage sometimes talks directly to WAN edge, but most of the time it talks through vSmart. We'll talk about those things also in detail later. But as of now, what I want to say is vManage can speak to vBond, WAN edge, as well as vSmart. And most of the time, it sends the configuration through the vSmart to the WAN edges. And those configurations that is not the control plane related, but common for all WAN edges need to be sent, will be sent directly by vManage. But those things that determines the control plane will always go through the vSmart. vSmart is the one which, as the word says, controls, which decides the control plane for all the traffic flowing in between edges. So these three we call it as controllers, and all these three are VMs. Now to connect between the controller and the WAN edges, we need network, a medium, and that is the service provider's transport. Service provider provides us the reachability between the edges as well as to the controller. So the transport is of various types. To tell that there are various type of transport, they have put two different color. There may be many type of transports. Here simply they want to say there is one MPLS connection, there is one IP internet connection, acts as a transport. So transport here it means underlay. The underlay.
Even it can be my SIM router as well, right?
Come again?
Even it can be my 4G SIM router.
Yes. Anything. Yeah. Yeah, in future, those things are very likely to be used in a very big level. Um, yeah. So for the mobility, even today we have it, but in future it will be more bigger level. Next is the WAN edge itself. As we saw earlier, there are two different type of edge devices. One is from the web tailor. The other one is from Cisco. So if you see C edges, they are called as Cisco edges, Cisco device. V edges are web tailor edges. And now we don't have the name V edge or C edge. Cisco has replaced it with WAN edge. There is no web tailor anymore. So what do we see here is the sites have got edge devices, one or two, maybe redundant edge devices. We can run VRRP if you have redundant edge device on sites. We can run VRRP and for redundancy, and then this is a data plane. The control plane is a floating one. vSmart provides the control plane. vSmart decides who can talk to whom, via what path they will communicate based on the color, based on the T-log, and accordingly the routing table on the edge devices are going to be built. So the control plane is not local to the edge device. It is in the vSmart. It is the vSmart, the one who decides the path for destinations on behalf of edge devices. See, these are the protocols that are involved. This is very less number of protocol here they mentioned. There are many more. Here what we see is overlay management protocol. OMP reports to vSmart. Here actually vSmart is that they are not showing it clearly in this picture. So the sites, the edge devices, and the vSmart, they communicate using a protocol called OMP, Overlay Management Protocol. The sites, they advertise their networks, their LAN networks. using OMP via transport VPN called VPN 0. We'll talk about VPNs later. So this protocol OMP still works on a tunnel interface only. That's why I brought that terminology called VPN. So overlay, but using the underlay, the physical WAN connection. If you will see I'll try to show it on the next class. If you will see wait, I have this in another batch video. Let me show. It's VPN 0. This is the one which is glue between the physical and physical and the overlay. So VPN 0 uses the physical interface G00. This is a WAN facing interface. God bless you. And then it's a tunnel interface, you see. It has got a tunnel on overlay on it. For tunnel, these are the features like encapsulation should be using IPSec. Color is MPLS. And you see HTTPS is allowed. You see some of the defaults. We can change these things. Let's go back. So OMP never talks to one side won't talk to other side using OMP. Side to side communication will never use this protocol OMP. OMP is only between the edge device and the vSmart. Yeah. Sometimes they also talk to vManage. That's why you said controller. I appreciate that, but most of the time it is only with vSmart. And then
Advertise the internal private network which is there in one of the site, any site.
Correct.
And so this OLP, it's not a single packet, it can be multiple packets because I can have a lot of internal networks which I need to send it to vSmart. So it means there will be multiple OLP packets which will be coming. So they build a packet and then they send it.
Yeah, updates are sent like that, So each site they send the updates, route updates, and many more things. I'm just giving you only one thing called route update. There are many more things advertised. System ID, many more things, site ID, and many more things go through OMP. That helps to picture. That helps to understand who is connected where, and vSmart knows now every. Okay, you have already gone through DMVPN assignment which I gave you. In that, if you see, the hub router knows about all spokes because all spokes come to the hub and they register themselves by providing the tunnel IP address as well as the WAN IP address. So hub knows everyone. Likewise, vSmart knows every network now. Now, vSmart also has got connection to vManage. According to the policy that you have defined in vManage, now vSmart will decide to whom I should reflect routes and whom not to reflect. Meaning, vSmart knows about all sites LAN network. But Site 1 LAN networks may not be given to site 2 because vManage don't allow. According to vManage, site 1 cannot talk to site 2. So vSmart will advertise it to site 3 but not to site 2. Why I'm saying this, just to tell you who decides the 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 path routes for the sites. It's all vSmart decides the routing table of each site. It is vSmart the one who decides who learns what. So the control plane is not on the edges. It's outside floating, vSmart. So for those sites that are allowed to communicate, they form tunnel using TLog. TLog is not just one small entity in it. It has got a lot of things through which it can identify the remote edge. So using TLog, the established tunnel between the sites, and now once the tunnel is established, the traffic flow happens over the tunnel, over the overlay. And now this traffic that goes through the tunnel can be GRE, can be IPSec, encrypted. Means encapsulation can be using IPSec, can also be using GRE. That's what we decide. We punch in it, small radio button that you need to go and punch in. Let me quickly show you that also. Actually, there will be one advance button. We need to click on that. Because it's video testing time, I need to wait. I'm explaining something else and then okay, here is that. Yep. You see? You see here? Ah. IPSec is actually default. No, sorry, it's not default. Both are off by default. We have enabled IPSec. If it is default, you will have a tick mark like this. So GRE off is default. Likewise, IPSec off is default, but here the icon has changed, which means configured. These things matter. Now, if you have a tick mark, in BGP we have attributes. So if first attribute is a tie, it will go to second attribute. If second is also tie, only then it will go to third attribute. If third is also a tie, they will go to fourth. Likewise, in SD-WAN also, while choosing a path, there is an iteration process. Here also preference and all will be checked. Site ID, preference ID. So there should be some tiebreaker. So preference is one of the attribute in path selection.
Sir, I have three doubts actually. Since you told the edge will advertise its routes via OMP and into the vSmart. So now vSmart should also use OMP to populate back those IP based on the policy which is configured in vManage.
Right.
That is again through OMP.
Yes. Back via OMP.
second question was, let's assume that site 1 has all the private IP somewhere in 10 network or 192.168 network. Even if site 2 internal network, if it has the same IPs, so will it not create some problem, or how will that be taken care?
See, they all have different VPN numbers. So there's no issue.
Okay. And second one, third last question is, you have written IPSec/BFD. What is that BFD?
Okay, BFD is also another protocol which is used in the uh, in the tunnel between the sites. Bidirectional forwarding, forwarding failure detection. It is to tell the edge device that there's something going wrong with this current path. You need to choose second path. Something like this is for identifying the failure very quickly.
Okay. So this can be for both IPSec as well as GR.
Yes, yes.
Bidirectional forwarding.
Failure detection.
Bidirectional failure detection. Okay. So that's okay.
It is bidirectional forwarding detection protocol. It is simply a hello mechanism that detects failure in the network. Only for this purpose we use BFD. Again, it's now that BFD is now very commonly seen in network, not only in SD-WAN. It's very common. OSPF network, BGP network. For fast convergence, they use this to identify the failure. So we see some of the uh, important protocols and components that makes the SD-WAN work. One is the TLS and DTLS and transport layer security and datagram transport layer security. This is one protocol that you will see between the WAN edge and smart as well as with vManage. More detail we will see in coming days. And then we got OMP, which we just spoke. We got BFD, which we just spoke to identify the link failure detection. BFD, bidirectional forwarding detection, which identifies the failure of the link. And then TLog. TLog is going to provide you the tunnel between the edge device as per the policy. Okay, here it is in detail. TLog is transport locator, which is an analogies to Lisp. That's why we learn Lisp or locator or routing locator. Example, two TLogs will be two TLogs if we have one MPLS and one IP transport. So if edge device have got two connections, then there's going to be two separate TLog because you need to separate tunnel to determine to differentiate both the paths. So for each path there will be one TLog transport locator. BFD bidirectional forwarding detection protocol is used to monitor the real-time condition of underlay transport network. So if something goes wrong with one of the paths, like say IP path has gone bad, so the traffic that was using the IP underlay should be now shifted to. It's actually physical interface failure that will determine the overlay. See, if a tunnel is established via MPLS one path, and if the link fails, the physical link fails, then tunnel will be broken. So immediately when the physical interface goes down, there may be another redundant MPLS connection from your edge device. So there should be a new T-log provided to those packets. A new tunnel need to be established by the alternate MPLS path to take fast decision in switching over the traffic from one tunnel to another tunnel. BFD is needed for fast convergence. So BFD is on the physical interface. This works with routing protocol like BGP and OSPF. We can use static route also between the customer, between the edge devices, between the edge device and the service provider network. But sometimes people wants to have only a default route to the ISP. They don't want to run any routing protocol. In such cases, the BFD can't be used. BFD is only when you use some protocols. We'll be seeing more on this again. Next, OMP, Overlay Management Protocol to manage the overlay network. OMP overview. OMP is a TCP-based extendable control plane protocol. TCP-based control protocol. It runs between WAN edge and vSmart. Next is TLS and DTLS. TLS stands for Transport Layer Security. DTLS, Datagram Transport Layer Security. Both are TCP. I'm sorry. One is TCP, the other one is UDP. But both are secure. It's only between the WAN edge and the vSmart.
I saw in one of the documents or something showing OMPPS. So it showed this even V1, vSmart, vManage. So everyone showed that.
Okay. That is. See, logically, OMP carries the route information. Why should route information of one edge need to go to vBond? So in that angle, if you see, peering maybe that's just for neighborship, but what do they share with them matters. Actually, the WAN edges share things to vSmart only, definitely not at all to vBond. Nothing it shares to vBond, nor to vManage. So, more appropriate answer is it runs between the WAN edge and the vSmart. Even this picture explains the same to you. But this is regarding the TLS and DTLS. Yeah, sorry, now I remember. I did not read like this OMP. I read like DTLS and TLS runs between the vSmart and Vantage as well as vManage and VH. This protocol runs between both vSmart as well as Vantage, also between vManage and Vantage. So TLS and DTLS also runs between vSmart and Vantage. The purpose is different. The purpose of this protocol TLS and DTLS, you see there, it's only for tunneling. forming tunnel. But the content inside the tunnel is carried through OMP. As we saw, BFT is only for failure detection on the physical interface, whether the interface has gone down or come up, how much is the latency, is there any jitter, will there be any packet loss, MTU on the IPSec tunnel, so on.
That BFT runs for some 60 seconds or what?
Definitely, it's a hello packet sent in between. There should be some timer, not for 60 second and all. It is very less, like 5 second.
Oh,
Only then it can give you a fast convergence. Again, what we see here is what OMP carries. OMP carries the T-log information, means your LAN network information to vSmart. And vSmart is the control plane. That's what here they put in the middle. And vSmart decides what the WAN Edge 2 need to learn about WAN Edge 1. So you can see the arrow mark down coming. So the routing table, the T-log for WAN Edge 1 comes to WAN Edge 2 through vSmart. So in order to reach the network of WAN Edge 1, these information that is coming from vSmart is very important for WAN Edge 2 to know.